Hello Year 9 and welcome to our lesson on specific heat capacity. So we're still doing physics. Unfortunately we are back to calculations again, but this is a really important calculation because we have a required practical to do with specific heat capacity, which we will obviously not be doing this week because it's lockdown, but there is a virtual way of doing it. So that's what we're going to be doing for most of the lessons this week, but this lesson is just the theory behind it. So what I want you to do is I want you to write down the date and the title and the LO, and I want you to try the starter task, please. So pause the video here and I will continue in 5 seconds. Okay, starter task. What does work done mean? So work done means energy transferred mechanically. So if you have transferred energy, then you have done work. So if you have a pen on your desk right now, if you pick it up to mark this question right or wrong, then you have transferred kinetic energy into that pen and also gravitational potential energy because it is now above the ground. So you have done work. Okay, so work done is energy transferred. Number 2, what two things affect gravitational potential energy on Earth? So I've said on Earth because obviously gravity affects gravitational potential energy, but it's always the number 10 on Earth. Okay, so the other two things that affect it would be mass and height. Okay, number 3, what two things affect kinetic energy? So kinetic energy is when anything is moving, and the things that would affect that is speed and mass. So give yourself a mark out of 3 for those questions, please. So if you've been on holiday and you've danced on the beach at sunset or walked along it if you're boring, you might notice that the sand is very hot still, but the sea is cold. So if you go towards the sea and put your feet in it, it's cold, but the sand might still be hot. And there is a reason for this, and that is specific heat capacity, and that's what we're going to be going through today. So here we have the sun, and we have a beautiful drawing of the beach. So there's the water and the sand. So the water and the sand are currently the same temperature. So the energy comes from the sun and it is transmitting the same amount of thermal energy to the sand and the water. But the water has a small temperature increase, whereas the sand has a large temperature increase. Okay, so the sand gets hotter than the water. It really hurts your feet to walk on the sand sometimes, and then as soon as you get on the water, it's fine. But we're still getting the same amount of energy from the sun hitting the water and the sand. Okay, so putting the same amount of heat into some materials gives a bigger temperature increase than other materials, and that is the basis of specific heat capacity. So we put the same amount of temperature onto the sand and the water. They're both right next to each other. The sun is putting the same amount of energy onto both, but some materials have bigger temperature increases than other materials. So the sand would heat up more easily than the water, even though they're both getting the same amount of heat energy. Okay, specific heat capacity. So the specific heat capacity of a material is the amount of energy required to raise 1 kilogram of material by 1 degree Celsius. I want you to write that down, please. So write down the definition of specific heat capacity. Okay, so it's the amount of energy required to raise 1 kilogram of the material by 1 degree Celsius. So if you have 1 kilogram of water, then the specific heat capacity would be how much energy you need to use to raise the temperature of that material by 1 degree Celsius. So the formula for this is energy equals mass times specific heat capacity times temperature change. So write that down, please. So SHC is just the shorthand version of writing specific heat capacity, because obviously that is a mouthful and it takes forever to write. and temperature change. Make sure you put temperature change, not temperature, it's the change in temperature. Okay, so energy equals mass times specific heat capacity times temperature change. And the units for this are: energy is measured in joules as always, mass is measured in kilograms, temperature change is measured in degrees Celsius, and specific heat capacity is measured in joules per kilogram degrees Celsius. Okay, so get those units down as well, please. Pause the video here and I'll continue in 5 seconds. Also, just to mention, you do not need to remember this formula off by heart. It will be given to you on a sheet in your exams. So there's a sheet with some formulae on it, and that will be given to you in your exams, and this is one of the ones that you don't have to remember. You need to remember how to use it, you don't need to remember what it is off by heart. Okay, rearranging the formula. So draw a formula triangle, please. At the top we have energy, and at the bottom we have mass times specific heat capacity times change in temperature. Now this funny symbol here that looks like a triangle, that is the Greek letter delta, and that means change. Okay, so triangle T means change in temperature. So if you are not going to remember that that's what that means, then write it down, please. So triangle T equals change in temperature. Right, and rearranging it. So if we want to find out the specific heat capacity, we cover it up, and that will leave us with specific heat capacity equals energy divided by mass times change in temperature. Okay, if we want to know what the mass is, we cover it up, and we are left with mass equals energy divided by specific heat capacity times change in temperature. And the last one, if we want to know what the change in temperature is, then it is change in temperature equals energy divided by mass times specific heat capacity. Okay, so that is how we rearrange the formula if we have to. Okay, here we have a table of materials and their specific heat capacities. So this here, let's take water for an example. This number here, 4,200, is how many joules of energy it would take to increase 1 kilogram of water by 1 degree Celsius. Okay, so the bigger the number, the more energy it needs, so the harder it is to heat up. Okay, so I'll say that again. This number here is the amount of energy that the material needs, so 1 kilogram of the material needs to increase by 1 degrees Celsius. Okay, so if we take oil as an example, if we have 1 kilogram of oil, then we will need 2,100 joules of energy to heat up 1 kilogram of that oil by 1 degree Celsius. Okay, so a kilogram is almost like a litre, so if you were putting water into your kettle and then you heat it up, so if you put 1 kilogram of water in your kettle, it will need this much energy to heat up by just 1 degree Celsius. Okay, so here we have all the specific heat capacities of these materials, and I want you to do the questions below, but I'm going to go through the first one of each with you, or I'm going to help you. Okay, so use the information on the table to help you explain the following statements. So a mass of lead heats up more easily than the same mass of aluminium. Okay, so we've got aluminium here, and we've got lead here. So Pb is the chemical symbol for lead. If you don't know what any of these are, then you need to get your periodic table and look it up, please. So you should be familiar with these by now. So we've got aluminium, iron, copper, and lead. So our question is, a mass of lead heats up more easily than the same mass of aluminium. So here, lead only needs 130 joules of energy to heat up by 1 degree Celsius, whereas aluminium needs 900. So we've got a kilogram of lead, a kilogram of aluminium. Aluminium needs more energy to heat it up by 1 degree Celsius. Therefore, we know that lead heats up more easily because we need less energy to do it. So they're both increasing by the same temperature, but lead needs less energy to do it. Okay, questions at the bottom. How much energy is needed for each of the following? So to raise the temperature of 2.0 kilograms of aluminium by 30 degrees Celsius. So we have our formula, which is energy equals mass times specific heat capacity times change in temperature. Okay, we've got 2.0 as the mass. We're looking at aluminium. Okay, so we've got 900 as the specific heat capacity, and the temperature change is 30. Okay, so I've written out what you need to do for that question, and you can put it into the calculator yourselves, please. Okay, so all of these questions here, I want you to do them all, please. And that is the end of today's lesson. So I hope you all have a wonderful day. I will be available on Show My Homework if you have any questions. Okay, bye.